So far, we know that if I have a square that's 1 by 1, the area is 1, and the side length is 1 because we can see it. We also know the square root of 1 is 1. If I have a square that's a 2 by 2, my area is 4. The side length is 2, partially because you look at it, but also because we know the square root of 4 is 2. And if we know the area of a shape, the side length is the square root. Those are opposite operations from the last chapter. What's the area of our 3 by 3 box?
9.
The area is 9.
Side length is 3.
And the side length is 3, partially because you can see it, but how is the side length related to the area? Square root of 9 is also 3. That always holds true. What's the area of this box right here?
Well, we gotta make it a box first.
Well, it's a square first, right? If you couldn't see it, you could draw the lines, figure out how many boxes are in there. How many boxes are in there if it's a 4 by 4 square?
16.
Ah, so the area is 16. What's the side length? 4. How is the area related to the side length? Because the square root of 16 is equal to, and that's a 4. Okay, and that's a 4. So those are all 1, 4, 9, and 16. Those are all what?
Perfect squares.
Perfect squares. Perfect squares, it's automatically going to be a whole number. What do you notice about all of these boxes? What do you notice about all of these squares right here?
Perfect square.
They're perfect squares. And how are these 4 different than those 2?
That one's on an angle. We gotta make triangles.
Ah, these are on angles. These are all straight across. So here's what I want you to notice. This label says it's 0 and 1. If I put a dot right here in the corner, it doesn't go anywhere and it just goes up 1 space. If I put a dot here, we don't rotate it anywhere, but it goes up 2 spaces. Here, I start in the corner and just go up 3. So this is almost like a coordinate pair. Do you see that? My X number doesn't go anywhere, but it goes up 3, 0, and 4. Okay? So these labels are going to matter because the next ones, you're right, they're cockeyed a little bit.
Hey, Jack.
For this one, is this going to be a whole number? No, it's not. Here's what I want you to do. This is a 3 by 2. So I went 3 in the X direction and 2. And I like how Cole said that. He goes, it's like a triangle. You're absolutely right. Do you see that triangle right there? It goes over 3 and up 2. Draw that triangle on your box. Do you see how this number right here, 3, 2, it's 3 over in the X direction and up 2 in the Y direction. Do you see that?
Jack, gotta zoom in.
And I will zoom in. Yep.
Oh, you are on the top.
So we know that this side length is 3. We know this side length is 2, but we need to know how long this side length is. How are we going to do that? How would we, notice there's a big old square right here, right?
Yeah.
Could we find the area of that square?
Yeah.
And if we know the area of a square, can we find the side length?
Yeah.
Yes. So that's what we're going to do.
So we have to go
So,
1, 2, it's about 3 times 59.
so you're kind of guessing, right?
So count the dots, but yeah.
There's an exact way to find the area of that square.
It'd be
Okay.
about 9.
Here's what I'm going to do. I always start in a corner and I go straight down and straight over to the next corner. Because what did I form now?
Another triangle.
A triangle with a 90-degree angle. How do you find the area of a triangle?
Base times height.
Base times height. And remember, the base and the height have to be perpendicular. So the reason I went straight down and straight across is so I have a base and a height. So we're taking what we learned last chapter and applying some geometry. Questions so far?
Did you draw these?
Yes. How big is this space? What's the area of this space, of this triangle that we just drew? If it's 3 by 2,
6.
6, but then you have to take half of it. So the area of this would be 3. You with me so far?
Hey, what is this paper? What number is this paper?
No number. It's the math that's on paper. No number. You can recycle it. Right now, you should be able to do this with me and see why we're doing it, not on your own. Do you see how we got the area of just this space? You went straight down and straight across. 3 times 2 is 6, and then half of it, yes, it's a right angle, so that's the base and the height. Half of that is 3. Ask me a question. What questions do you have? No? I'm going to go from this next corner, and I'm going to go straight up. And it happens to hit this line, so I have another 90-degree angle. Can I find the area of this space right here? It's a 3 by 2, which would be 6.
How do you pick what way you going?
And you go straight from the corner up and straight. So you go from corners till they meet at a 90-degree angle. That's a great question. And you're right. There's going to be, what's the area of this space first though, Jess? What's the area of this space? If it's a 3 by 2, 3 times 2 is 6, and half of that is 3. Because the area of a triangle, is half of the base times the height. Jess said, I see another one. He's right. If I go from this corner straight across, and there's another one. And all of the triangles are 3 by 2. Do I have to keep figuring out how big they are if they're exactly the same? This is a 3 and this is a 3. Why is the middle box 1? You're right. Because it's just an area of 1. It's a 1 by 1. So 3, 3, 3, 3. There's 4 3s, which is 12. Plus 1 more is the area. It's 13. Well, how big must the side length be? If I have an area, if I know the area of my square, the opposite of squaring a number is the square root. You're right. So my side length,
It's like 60 point something.
no, it is not. 6 point something.
Yeah, it's 6 point
Tegan, tell me why you think it's 3 point something.
Because the square root of 4 is 16 and the square root of 16 is 4 and the square root of 9 is 3.
Good. It's got to be between the perfect squares 9 and 16, so it's got to be between 3 and 4. It's almost 3.5, right? What does the calculator say?
3.60.
Ooh, we were pretty close. So we're using that skill from last chapter too.